mm. Material properties are given. It is Young's modulus is 210 GPa and buoyance ratio is 0.25. They also specified the density, which is specified in terms of kg per meter cube. So you need density to find the mass moment of inertia. Okay, so that's why if you want to perform a model analysis, definitely you need to define the value of the density. In the previous case, we didn't add this value because it doesn't. Those problems doesn't need the value of. It doesn't depend on the density. But in this case, you need to specify that. If you clearly observe, no, the beam has a cross section of 15 to 40 mm. So I want to specify all the dimensions in terms of meters. Okay, lengths in terms of meters and forces in terms of newtons. Okay, so let me move to mechanical APDL. So as preferences, I will pick structural. So in the previous case, I choose thermal, but now I'm picking structural. Click OK. Let's move to preprocessor and define the element type. Add. I'm picking the beam element. So in this, I want to go for 2-node beam element. Let's select that option. Click OK. So let's check whether you need to add any information under options. I'm selecting option. So there is no need to define anything here. Click OK. Close the window. So add the material properties. I'm creating a material model. Under structural, I'm creating a linear, elastic, isotropic. So since I want to specify lengths in terms of meters, you need to express this Young's modulus in terms of pascals. No, Pascal is 1 Newton per square meter. So let's convert the specify the Young's modulus in terms of pascals. Okay, here they specified Young's modulus as 210 gigapascals. So let's add that value. 210 10 power 9. Buoyance ratio is 0.25. Okay. So after defining the material constants, I need to define the density. Okay, let's add density. So the value of density is 750 kg per cubic meters. It should be 7,850. Click OK. So I'm done with the material model. Close the window. So let's define the section properties. Why you are defining section properties is for a beam, no, you need to calculate area moment of inertia. So in that case, you need to specify the cross section of the area. Sorry, the cross section of the beam. So that's why I'm being beam option. So since it is rectangle, I'll go for common sections option. Okay, you need to specify B and H. So see here you find these symbols now. So B is the width and H is the height. Okay, so they specified the dimensions as 15 to 40. I want to convert them in terms of meters. So B is 0.15 0.04 meters. And H value is 0.05. Okay, click OK. So I created the section. Now let me create the model. So model is very simple. I want to, since it's a cantilever beam now, I want to use linear elements, line elements, or sorry, beam elements. Beam elements are nothing but 1D elements, no? So I will create a line. Let's create key points. So I'm using inactive coordinate system. So key point 1 has 0, 0, 0. I'll just simply click apply. If you don't add values here, it will consider as 0. So that's why I will only press apply. So second point, the total length of the beam is 750 mm now. So X value should be 0.75 meters. Y and Z values remain 0. So I'll click OK. See, I created a point here, which is behind this. This is 0.1 and this is 0.2. Okay. Let me click a line. Sorry, create a line between those key points. So I'm opting line option. Straight line. Let's pick these 2 key points. Click OK. So I created the model. Now, after this, there is no need to specify the real constants. Automatically, it is going to create it is going to find the area of cross section since you specified the section properties. Now, let's move to meshing. Okay, go to mesh option. So I'll pick. I'll use this default attributes. Let's check whether it is picking correct values or not. So you already selected an element now. It is beam 188. It is picking that. Material number is 1. Real constant it doesn't need. So you didn't define anything. Once again, you're following the global coordinate systems. You keep it like this. Section number is 1. So you only have one section now. So that's why I'm opting for 1. Everything looks good. Click OK. So let me mesh this. So before meshing this, let's define the size control. I'll go for manual size. I will select the lines since you have only lines. You can go for pick all lines. Okay. So instead of calculating the element length, now I will go for element divisions. So I want to divide the whole problem into 75 elements. So I will pick number of divisions as 75. Click OK. So it is showing a preview. You didn't create the mesh. Only it is showing the preview. Until unless you create a mesh. Okay, you don't describe this model. So go to mesh option. So I'll use lines. Select that particular line. Click OK. So now we create a mesh. So after creating the mesh, we need to apply the boundary conditions. No, this end is actually fixed. So let me move to loads. Okay. So here I want to define the analysis type. Let's create new analysis. So in the previous case, up to now, I used only static analysis. But now I need to pick the model analysis. Let's select that option. Click OK. Okay. Define the loads. So let's define the loads. Okay. Click apply. Structural. I need to constrain all the displacements now here at this point. So I'm picking displacement option. You can pick on nodes or on key points. Okay. So I want to go for on key points. Let's select this. I'm selecting this particular key point. Click OK. You need to constrain all the degrees of freedom. So on the whole, 6 degrees of freedom, 3 translations along X, Y, and Z, and 3 rotations with respect to X, Y, and Z. So I will, instead of picking individually, I will pick all degrees of freedom, and here add a value 0. If you don't put any value, it will consider as 0. Click OK. So I applied the boundary conditions. Now let me move to solutions. Okay. Let me move to analysis options. Since it is model analysis now, so it is asking us to select a type of method. So I'll go for the default method, block option, this one. And you need to specify the number of modes to be extracted. So for my convenience, I will put it as 5. This looks good. Click OK. So starting frequency and end you need to mention that. I will put the default values as 0, 0, and 0. Click OK. Then let me solve this. Move to solve option and begin the current load step. Okay, it is clearly specified analysis type as model solution, and you're extracting number of modes as 5. So everything looks good. Okay, let's click OK. Everything looks good. It says the solution is done. Click close the window. Okay. So let me move to post processing and view the different modes. On the whole, you created five modes. So under general post processing, let me view the results. So go to plot results. I want to view the deform shape. I'll go for the last option. Okay, deformed and undeformed with edges. Let's click this option. Click OK. So before this, let me read the results once. So I'm reading the results. Let's pick the first set. Okay, let's check whether it is picking or not. So go to plot results. Displacement. Click OK. See, these are the, since I didn't read the results, it is showing us some error. So now if you see, this is the first mode, and you can view the counterplot of the displacements. Okay, if you want, you can also use isometric view. Okay, move back to front view. So this is the first mode. Okay, it says substep 1 now. Substep 1 indicates it's mode number 1. Okay, so similarly, again, if you want to read the second set of results, go to read results. Pick the next set. Okay, let's select this option, next set. Once again, move back to plot results, counterplot. Okay, I'm picking nodal solutions. Once again, I'll pick displacement vector sum. Click OK. So this is the next mode. Okay. Once again, I want to view the isometric view. It looks like this. This is a front view. Read the next set of results. you can play with these options, first set, next set, and so on. See, this is subset 2, no? So that indicates it is mode 2. Let's select the next set. Once again, move back to plot results. Nodal solution. Okay, displacement vector, sum. Click OK. So this is the next mode shape. Okay. This is isometric view. So these are the different modes. Let me move to next set. Once again, move back to plot results. Nodal solutions, displacement vector sum. Click OK. So this is the next mode. Actually, it is deviating along z-axis. Okay. From the front view, it looks like a line, but it actually has a different mode shape. Am I clear? Let's read the last one. So here it is mode number 4. It is clearly specified as subset as 4 now. Move back to read results. You can pick last set or simply pick next set. It doesn't. It has the same meaning in this case. Okay. Once again, move back to plot results. Nodal solutions, displacement vector. Click OK. See, this is the next mode shape. So this doesn't looks good. So in this way, you can extract the modes, different modes. You can also view the more different, deform shapes. Okay. So if you want to list results, use the same procedure. You can list the results. Okay. So for example, for node 5 or node, okay. So this is the result summary. It is showing the frequency of about different modes. Okay. So this, you can use this option, result summary. So hope you understood this. So if you got any doubts, please put in the chat box or you can unmute and ask the question.